You're welcome to the study of indices. Now, indices are just a special way of expressing large numbers. As you can see on the screen, a number like 1000, we all know that 1000 can be expressed as 10 times 10 times 10, which simply means 10 in 3 places. That's 10 to the power of 3. Similarly, we have here, I think this is 10 million with 7 zeros. This can easily be expressed as 10 raised to the power of 7. When we express numbers this way, we call the 10 the base, and then the 7 the index. In some parlance, you can call it the exponent or the power. Take for example here 128. 128 is what? Using a base of 2, is 2 times 2, which is 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64, and times 2, that is 128. In indices, we are told that we can simply express this as 2 to the index of 7 or to the power of 7. So we simply say that what? Indices are a special way of expressing what? Or expressing large numbers. Now, when we express numbers in this form, here we have 625, which is what? 5 raised to the power of 4. Of course, as I've said earlier on, 5 will be referred to as the base and the 4 as the index. So I have here m equal to what? N raised to the power x. N is the base and x is the index. The word indices is coined out of index being the plural of index. So indices comes out as what? The plural of index. Now, basic arithmetic operations can be carried on numbers that are expressed this way. And to do this, we have certain guiding rules. These rules we popularly refer to as the laws of indices. In this video clip, we're going to look at 2 of such laws. One, the law guiding multiplying indices, and the one guiding dividing indices. Here on the screen we have that a raised to the power of n, m rather, multiplied by a raised to the power of n, that this is giving us a raised to the power of m plus n. What does this imply? It means if I have a number, say 7 raised to the power of maybe 5, and I have the same number again, that is 7 raised to the power, let's say 4, that this is simply 7, simply add up the indices, 5 plus 4, and that will give us 7 raised to the power of 9. Of course, I know you want to tell me that, why do I have to start going through this? Can't I simply say 7 raised to the power of 5 is 7 times 7 times 7 times 7 times 7? Yes. And of course, 7 raised to the power of 4 will be 7 times 7 times 7 times 7. And that will give us 7 raised to the power of 9. That's very correct. But what about when the numbers start getting very, very large? Do we keep on writing all the bases? That becomes a lot of trouble. So the law of indices simply states, as we have here on the board, that if we are to evaluate 7 raised to the power of 5, we should simply say that this is what? 7 raised to the power of 5 plus 3. Though, as you have rightly said, we would have gone through the archaic method of listing out the whole of 7 raised to the power of 5 as 7 times 7 times 7 times 7 all the way, and 7 raised to the power of 3 likewise, and then we obtain 7 raised to the power of 8. But as I said earlier on, what if we had something like this? 8 raised to the power of 55 times 8 raised to the power of 20. Are you going to list out the whole 8 in 55 places and 8 in 20 places? Obviously, you know that will not be practically too interesting. Rather, you simply say, oh, 8 raised to the power of 55 times 8 raised to the power of 20, applying the law of indices that says, oh, we have two numbers that are the same base, 8, 8, multiplying themselves, expressed as indices. What do we simply do? Take the base 8 and add up their indices. That will be 55 plus 20. And that will give us what? That will simply give us 8 raised to the power 75. So that was it for what? For the law, for what? For the first law, where you have two numbers expressed in the same base and they are multiplying themselves. The rule simply says add up their indices. Next, we're going to look at when two of such numbers have been divided, like we have on the screen right now. The rule states here that if I have a number a raised to the power of m, that same number serving as a base again, a raised to the power of n. Sorry, let's erase this. We are looking at division. Now this expression, of course, can be written as a raised to the power of m. You agree with me that this can be written as all over a raised to the power of n, whichever one you want to use. And the law simply says that when we have this kind of system, we simply say that what? That a is raised to the power of m minus n. We use the exponent or the index of the numerator and what? Subtract the index of the denominator or the divisor. Again, let's look at 7 raised to the power of 5 divided by 7 raised to the power of 3. 7 raised to the power of 5 divided by 7 raised to the power of 3. Ordinarily, you will tell me that, oh, this is simply 7 times 7 times 7 times 7 times 7. All divided by what? 7 times 7 times 7. Of course, you say 1, take care of that. This takes care of that. This 7 takes care of this 7. And we have just 2 of them left. So you can express that way. But why? The rule simply says, why don't you just do 7 raised to the power of 5, that is the index of the numerator, and subtract the index of the denominator, and you have the 7 raised to the power of 2. Yeah, that's a summary of what we've just done. And we can simply do this as what? 7 raised to the power of 5 minus 3, which gives us 7 raised to the power of 2. Okay, applying the law there. Again, you can see if we have a very large number, we won't have that space to start listing out all of 8 raised to the power of 55, writing 8 in 55 places. Simply say, oh, the law of indices is so interesting. It says, oh, if this is 8 raised to the power of 55 divided by 8 raised to the power of 20, simply subtract the two indices, that is 55, subtract 20, and that will give us 8 raised to the power 35. So now we have considered two of these laws, a raised to the power m, as we have seen, times a raised to the power n is equal to what? A raised to the power of m plus n. And if you have a raised to the power of m divided by a raised to the power of n, the rule simply says subtract the indices. So that's it for the first two laws of indices. In the next video clip, we will look at the law that guides us when the index is negative. So we'll be looking at the negative index.